Welcome to Cosmic Compass, where we journey through space and time to uncover the mysteries of our universe. When we think of Earth, we imagine a stable blue world perfect for life, but the truth is far stranger. For most of its history, Earth looked nothing like the planet we call home today. It has been a fiery ball of molten rock, a frozen snowball, a strange orange haze, and an ocean world filled with bizarre life. Earth is the place we call home. It's where we work, eat, sleep, and live out our daily routines. But how well do we really know it? We like to imagine Earth as the blue marble, a stable, life-friendly world. Yet this picture is only a snapshot of an ever-changing, evolving planet. If we zoom out across the cosmic timeline, we discover that Earth has rarely looked like it does today. In fact, for most of its history, it would have been unrecognizable. So let's take a journey back through deep time. Imagine alien scientists traveling across the galaxy, stopping by Earth at different points in its past. Depending on when they arrived, their impression of our world would be completely different. At times, they would have seen a fiery wasteland. At other times, a frozen ball of ice. And eventually they would have witnessed oceans teeming with strange creatures. What would they have thought if they saw Earth 4.5 billion years ago, or 2 billion years ago, or just a few 100 million years ago? Let's find out together and retrace Earth's dramatic story. Before we dive in, let's acknowledge something important. Reconstructing Earth's distant past requires models, evidence, and educated guesses. Some aspects of this story are well supported, others remain debated, and future discoveries may rewrite parts of what we think we know. But based on our current best science, we can paint a picture of how Earth has changed a story that is both grounded in fact and rich with imagination. So let's begin at the beginning. Picture Earth not as the lush blue planet we know, but as a violent molten sphere. Around 4.5 billion years ago, Earth was still an infant, less than 100 million years old. Its surface was a swirling ocean of lava, glowing under a sky choked with dust. The atmosphere was thin, made mostly of hydrogen and helium, and quickly stripped away by the solar wind. Without a magnetic field to shield it, the young planet was bombarded by radiation from the sun. And as if that wasn't enough, it was constantly battered by asteroids and comets. Each collision added mass to the planet in a process called accretion. Imagine a ball of sticky tar or chewing gum growing larger as more debris stuck to it. This was how Earth gained its bulk, but some collisions were far more dramatic. One enormous impact with a Mars-sized protoplanet nearly destroyed Earth, but instead gave birth to our moon. The debris flung into orbit gradually coalesced, forming the familiar companion we see in our skies today. Amid this chaos, the seeds of something remarkable were being sown. Many of those asteroids carried water locked within their minerals. When solar wind particles struck them, oxygen was released and combined with hydrogen, creating water molecules. Over time, these impacts delivered large amounts of water to Earth's surface. As Earth cooled, heavier elements sank toward the core, while lighter ones rose. Volcanic eruptions spewed gases like carbon dioxide, ammonia, and water vapor into the air. Eventually, this vapor condensed, giving rise to the first oceans. To an alien visitor, this world would have seemed hostile, too hot, too violent, too unstable. Yet, within the molten rock and asteroid debris, the building blocks of life were quietly gathering. Now let's fast forward 2 billion years. The fiery chaos has subsided. By 2.5 billion years ago, Earth had developed a solid crust, a magnetic field, and vast oceans. But it still didn't look like the Earth we know. If our alien scientists had arrived, then they would have seen a planet shrouded in a pale orange haze. The atmosphere was thick with methane, giving the sky an otherworldly colour, much like Saturn's moon Titan today. Above the moon loomed huge and close, much larger in the sky. than it appears now because it was still drifting away at a steady pace. With its stronger gravity, the tides were far more extreme, shaping coastlines with relentless force. This version of Earth would feel alien, almost surreal, like something out of a dream, but hidden in its oceans, a revolution was underway. Primitive bacteria, specifically cyanobacteria, had evolved the ability to capture sunlight and use it to power their metabolism. Through photosynthesis, they converted carbon dioxide and water into nutrients, and in the process released oxygen. This event, called the Great Oxidation, permanently altered Earth's atmosphere. For the first time, oxygen began to accumulate in significant quantities. Over millions of years, this led to the formation of the ozone layer, which shielded the surface from the sun's harmful radiation. In shallow seas, colonies of cyanobacteria built curious rock-like structures called stromatolites, layered mounds of microbial slime and sediment. These structures can still be found today in places like Shark Bay, Australia, and they remain some of the oldest visible evidence of life on Earth. At this stage, bacteria ruled the planet. There were no plants, no animals, no forests, just microbial life, quietly transforming the atmosphere, making it possible for complex life to eventually arise. To us, it may seem simple, but to our alien scientists, this discovery would be breathtaking. For the first time, Earth had shown it could harbour life. Let's jump forward again, this time to about 650 million years ago. If our alien visitors expected to find lush oceans filled with new forms of life, they would instead be shocked. Earth had entered one of the most extreme ice ages in its history, a period known as the Cryogenian or Snowball Earth. At this time, the entire planet may have been covered in ice. Glaciers stretched from the poles to the equator, sealing much of the ocean under kilometres of frozen crust. Temperatures at the equator were as cold as modern-day Antarctica. From space, Earth looked like a gleaming white marble, more like a frozen moon than a vibrant planet. A massive supercontinent called Pannotia sat near the South Pole, though it would have been hard to distinguish beneath the ice sheets. How did this happen? Scientists debate the causes. Some point to giant volcanic eruptions that filled the atmosphere with light-blocking ash. Others highlight how photosynthesizing microbes may have drawn down greenhouse gases, tipping the climate into a runaway freeze. Orbital cycles known as Milankovitch cycles likely played a role too. Most likely it was a combination of factors. On the surface, it seemed life had been crushed by the ice, but beneath the frozen oceans life persisted. Cyanobacteria clung to hydrothermal vents, while red algae evolved in the dark waters. Life was battered, but not extinguished. To our alien scientists, this world might have looked dead, but they would be wrong. Life was waiting, enduring the cold, ready for the next great transformation. 300 million years later, Earth had thawed, and what a difference it made. By the Devonian period, around 360 million years ago, the planet had become almost unrecognisable compared to its icy past. Temperatures were warmer than today, with tropical seas that averaged over 25 degrees Celsius. The supercontinent had broken into smaller land masses, with Gondwana dominating the southern hemisphere, and most dramatically, life had exploded in diversity. The Cambrian explosion had already filled the oceans with a dazzling variety of creatures, and by the Devonian, the seas teemed with trilobites, brachiopods, and early vertebrates. Gigantic armoured fish like Dunkleosteus, stretching up to 10 metres long, prowled the waters. Some resembled prehistoric submarines, with jaws powerful enough to crush almost anything. Meanwhile, plants had conquered the land. Primitive forests spread across the continents, forming the first stable soils. But these were not the trees we recognise. Vast fern-like plants and strange tree-like fungi called prototaxites towered up to 8 metres high. They looked alien, but they reshaped the landscape into green shaded habitats, and in shallow swamps, a few adventurous fish had begun to crawl onto land. Ichthyostega, one of the earliest tetrapods, waddled clumsily on stout limbs, breathing air with simple lungs. These pioneers were the ancestors of all land vertebrates, including, eventually, us. To our alien scientists, this must have been astonishing. The planet they had once seen as molten then frozen was now alive with forests, oceans, and creatures that walked on land. Earth was no longer just a survival story. It was a flourishing, complex ecosystem. Of course, the story doesn't stop there. After the Devonian came new extinctions, new ice ages, and new bursts of life. Amphibians gave rise to reptiles, reptiles to dinosaurs, and eventually mammals. Entire dynasties of creatures rose and fell. And one day, long after the alien scientists' visits, humans emerged a species capable of looking back at this vast history and telling its story. If our alien visitors returned today, they might finally recognize Earth as a world filled with intelligence, curiosity, and the ability to understand its own past. Or perhaps they would simply marvel at the improbable journey that led from a molten sphere to a planet of cities and satellites. Earth has worn many faces: a lava world, a pale orange haze, a frozen snowball, a thriving ocean planet. At every stage, it seemed like an alien world, and yet each transformation paved the way for the next. This is the story of resilience, of constant change, and of life's remarkable ability to endure. Perhaps that is Earth's greatest lesson, that even in the harshest conditions, new beginnings are always possible. So here's a question for you. If alien scientists did visit Earth again, what would they think of us? Would they see a species worthy of its planet's long history, or one that has yet to prove itself? Thank you for joining us on this journey through time. If you enjoyed exploring Earth's ancient past, make sure to subscribe to Cosmic Compass for more stories of planets, stars, and cosmic mysteries. And let us know in the comments which version of Earth would you most like to see for yourself. Until next time, let's keep exploring together.